This statement explores whether the number of samples in each fold could differ. Remember, GroupKFold aims to keep samples from the same group together. In our scenario, each group has 3 samples, and we have 3 folds. Therefore, each fold will receive exactly 1 group, resulting in 3 samples per fold. So, this statement is false. It could be true if the groups had varying sizes. This statement focuses on whether every group will appear in every fold. With 3 folds and 5 groups, GroupKFold will distribute groups across folds such that every group is present in only one fold. Consequently, every group is represented in the folds. This statement is true. This explores if each fold will have 5 samples. The dataset has 15 samples, divided into 5 groups of 3 samples each. Since we are using 3 folds, a simple and balanced division would assign 1 group to each fold. Thus, each fold would contain 3 samples. Hence, this statement is false. This statement sets the stage. We're working with a dataset of 15 samples and we'll be using a technique called GroupKFold to divide this data into 3 different sets for testing and training a model. GroupKFold is a way to do cross-validation while making sure similar items stay together. The core of our task revolves around these 15 data points. We need to split these carefully, considering that similar samples need to be grouped together, so our model doesn't get confused. Here's how our 15 samples are grouped. Notice that samples 0 to 2 belong to group 1, samples 3 to 5 belong to group 2, and so on. This grouping is important for the GroupKFold technique because it helps keep similar samples together during cross-validation. This line shows that we're using a specific type of cross-validation known as GroupKFold. The n_splits equals 3 feet part means we want to split our dataset into 3 folds, 3 separate groups, for cross-validation. The key here is, GroupKFold ensures data points within the same group stay together throughout the folds. This illustrates how the data is split. In the first fold, we have all the samples from group 1, samples 0, 1, and 2. Similarly, fold 2 contains all the samples that belong to group 2. The same pattern continues. Fold 3 includes only samples belonging to group 3. Fold 4 uses samples from group 4. And finally, fold 5 uses samples from group 5. This statement is incorrect because each fold contains 3 samples. GroupKFold keeps groups intact. It doesn't focus on creating folds with the same number of samples. This is correct, that's the whole point of using GroupKFold. It's designed to prevent splitting groups across folds. This is incorrect for this specific example. However, if the group sizes were different, the fold sizes would vary. Correct. With 3 folds and 5 groups, each fold must contain a unique group in this scenario. The dataset contains 15 individual samples or data points that are going to be used in the cross-validation process. These numbers represent the group each sample belongs to. Notice that there are 5 groups, 1, 2, 3, 4, and 5. And each group contains exactly 3 samples. This grouping is crucial for the GroupKFold technique. This specifies that we want to split the data into 3 folds for cross-validation. This means the dataset will be divided into 3 separate subsets for training and testing the model. This is a specific type of cross-validation technique from the scikit-learn library. GroupKFold ensures that samples belonging to the same group are always in the *same fold. This is important to prevent data leakage, especially when dealing with grouped data, like time series data where consecutive points are highly correlated. The first fold will contain all samples belonging to group 1. In this case, 3 samples. The second fold contains all samples from group 2, again 3 samples. The third and final fold will have the remaining groups, 3, 4, and 5, each contributing 3 samples, resulting in a total of 9 samples in this fold. This statement is false. Because of how GroupKFold works, and the way the groups are structured, there are 3 samples in each of the folds. This is true, it is the defining feature of GroupKFold. Samples in the same group are kept together, preventing them from being in different folds and potentially causing leakage of information. This statement is false in this specific example. Each fold contains precisely 3 samples. However, if group sizes were unequal, this statement could be true. This is false. While all groups are present across the 3 folds, not every fold contains all groups. For example, fold 1 contains only group 1. Only statement B is completely correct.